Hey, this is Sam from Battery Brigade, and I'm just going to run through the software side of this project real quick for you. So first off, if you're starting the program, you're going to go to RT Lab, which is the software that Opal RT provides so that you can actually communicate with the Opal RT box, right? So first we're going to compile the model with build, and then we're going to load the model onto the board, and then we can execute it. And once you start executing it, you're going to get our GUI to pop up with live values. All right, so let's start over here. With this little opcon block, this is where it's transferring all the values from our master side, where we're actually pulling the values from the Opal RT box, and we're running them through here, and they're outputting right here. So you can see our current value, our voltage of the battery, and some temperature values. And this down here is just kind of showing the value of the SSR. So right now, whenever you see a number other than zero, specifically four, because that's what we have it set to, it requires 3.5 volts to trigger an SSR. So it'll actually like allow current to flow through. So we just put 4 volts there. So right now, SSR1 is referring to charging. You can also see that up here with the user override. So if you select one, that means you're in charge mode. Zero, you're in discharge mode. That's also checked over here with our little voltage check. We have some safety stuff involved in the GUI. So this is checking if this is above 80% or below 50% of its max charge. So, excuse me. So once this gets up closer to about 3 volts, I currently have it charging. It should start to kind of fluctuate around 3 volts. So it'll start to discharge a little bit and then it'll go back to whatever this is set to. We also have some temperature checks going on. If the thermocouples read of temperature higher than 113 degrees Fahrenheit, that means that we're no longer in the safe range for charging. And if it reads more than 140 degrees, that means we have a serious problem and we just need to shut it down. So that's exactly what we have. Whenever we hit a little bit over 113 degrees or anything around 113 degrees, it will switch to discharging. And then if we hit 140 degrees, we're just shutting it down entirely right here. If you look down here, we have our serial communication, our TCP communication block. So right here, you can change how many amps you want to power the battery with. So right now, the power supply is set to 1 amp. Like I can go over here and I can change it to 0.75. And then over here, this would be where you would connect to the load, but we had some issues with the load that I believe has already been discussed. Right here, you can change the temperature of the environment chamber. So right now, I just change it to 75 degrees. There we go. Like always, there's this little record block, kind of looks like an alien. So it's actually taking all of these data values and pumping it into an Excel block. And then we can also, over here, let's go ahead and show it. Get that. So it takes a few seconds, but so I just selected it to switch to discharging. So in a few seconds, you should see SSR2 flash to 4 and this one flash to 0. One issue that we ran into with all of these safety checks that were involving this, it made it take a while to get to that point. Like you see, it just switched over, but it took a few seconds, and you can see the voltage of the battery starting to go down. Currently, I have the voltage on there set to, I believe, 0.75 amps, which is the C over 4. So on the lower side. And then once this gets a little bit lower, sometimes it'll start discharging, and with that delay, it'll go below the 1.9, which is something that can definitely be improved upon. So like right now, you see it's around the 1.9. We should see it start to switch. It's already triggered, but it's going to keep going down before this actually flips. See, it just now flipped at 1.5, and now it's starting to go right back up. That should be everything here. Let me go ahead and stop this. All right, and you'll see an Excel spreadsheet pop up that has the time value, the voltage. We have the time value, the current, the voltage, and then our 4 thermocouple values. But yeah, that's pretty much all on my side. I'm gonna go ahead and toss it over to Cody, showing the actual circuit. Thank you.
So this is our hardware organization table. This is our extension cord that we're going to be powering all of our stuff off of. These are our 2 DC supplies. This is our main DC supply. This is our main DC load. So this will be powering the battery. This will be discharging the battery. We come to our 2 switches. These 2 switches are going to determine whether or not we are charging or discharging the battery. So when we are charging, and we get to the battery, which is inside the environment chamber. Here's the positive and the negative terminal. Taped to the top are 4 separate thermocouples. These are taking our temperatures. Thermocouple amplifier. And if we follow these back, they go into Opal RT. Now here we also have these wires which are coming off of the battery as well. These are also going to Opal RT, and we follow all the stuff back to here. Inside, this is connecting to our Opal RT box. This is where we are pulling all of our data from. It's from these two. We also have our Ethernet cables connected to our Ethernet hub up at the top, which those are connected to environment chamber and load and supply. This is our current sensor. This is sending data to Opal RT, and it's being powered off of one of our DC supplies.